Hello everyone, I am Frums, and in this tutorial I'll be explaining how to use images and an extension of Images Spritesheets. Before we start, I'm going to show the images we're going to use. So first of all we have our simple image, just an alien. I also got a sprite sheet here, simple tile set that we're going to use. And the first thing we want to do is we want to load our images. Now, we don't want to do that in the update or the render method. We want to do that before we're actually starting to update and render our game, or at least our basic game here. And we want to do that in it. This is only called once, as I told you last episode. And what we want to do is we want to store the image in our basic game here. So let's say private image alien. This null. Now, because there's also an image in Java, Eclipse doesn't know which image to pick. We want to get the Slick2D image. And now in init, we're going to say alien is new image. And what we want to do in here is we're going to have to give the image the path towards the image. So in my case, this is data alien. So let's do that. .png. So now that we have loaded up this image here, we want to draw it to the screen. So let's say alien.draw. And we have to restart our program. And there we go. We have an image on the screen. But this is not where we want our image. We want to have it somewhere over here. So let's fix that. Let's say 200 by 200 for example. So this is the x200, y200, same as the drawstring. And as you can see, our alien is now over here. Now there's a lot of different methods that you can use to render a game. So I started up our game in debug mode. This allows us to just mess around with this a bit and see the changes. And because I don't want to actually click on this screen to be focused every time, I want to say application dot always set always render on true. So when this is on, it's gonna always render even if it doesn't have the focus. So let's restart it again. And as you can see, if I click here, it's still gonna render. So if I change this and save, it's gonna instantly update. And let's take a look at the different features of the image. So there's a lot of draw functions. There's functionality for you to have a color filter and for you to scale the image, both at the same time, and different methods for the size of which you want to render your image. So if you say I want it to be so much wide and so much high, you can use this method. So let's render a second one and let's just move it up a bit, the same height. Well, let's say it's 32 wide, but it's actually 46 high. So as you can see, we rendered the same image, but we said, well, we want the image to render 46 high. And because the image is only 32 high, it's going to stretch the image. And as you might guess, if you stretch both once, you can actually scale this. But there's also a scaling one over here. So let's put this at 400. As you can see, I scaled it by 2 times the size. So as you can see, we have 3 images here. And this is just a basic image. We can actually do a bit more than just drawing the image, and there's also a few images for drawing a flash of the image and drawing it sheared. So let's take a look at this one first. What it basically does is what you'll see right now. It's gonna attempt to render the image, but it's not gonna render with any color. So as you can see, that transparent pixels uh, don't get white, but everything else gets white. And this might be useful for example, if you have an enemy that you hit and you want to flash when they get hit, something like that, or in a dark spot with lightning. Um, that's what it can be useful for. There's also the sheared one, and you may or may not know what it does. So I'm just going to show it to you, and I'm going to put this alongside with our other images, and we're just going to say, okay, only do it horizontally. As you can see here, is that our image is it's a bit off. It doesn't look like, it doesn't exactly look like our normal image, and this is because we said we want to render an image starting at 500, 200, and then we said, but we want our bottom row of pixels to start 10 pixels later. So what you get is you get a diagonal here at the front of your image, and the larger you make this, the crazier it's gonna be. But there's also possibility to do this for the vertical one. As you can see, we will start the vertical shearing or a last row of pixels a bit later here, and of course you can also do it on the negative side where you want to be the row of pixels be a bit higher. So that's what you can use as well. There's also a draw warped method, and what this allows you to do is set the exact position of each corner of your image. This is done counterclockwise, but if we let's say our image started at 75, 75, and now what we want to do is our bottom left point, but let's just make it a bit off. So we want it to be still at 75, but let's say 150. Now our bottom right corner is going to be at 150 for now, and let's make it so that our bottom right is a bit higher than the bottom left. So let's say 125, and then the top right corner, let's just go crazy with this one and put it somewhere in the middle of it. And look at that, our images gone crazy. Well, draw warped, as you might guess, but if we fix these values up to be actually their proper values, this I think, and this was supposed to be that, and there we go, our image. So that's another function you can use. Because the draw function of an image is not exactly the most efficient function, especially for sprite sheets, because you will be drawing a lot of images from the same image, and basically you will be loading a lot of resources that you don't have to, and the way that the draw function works in Slick2D, it can be more efficient. And let's just remove this for now, And we're gonna add another image now. And this is gonna be the tile set. So we want to load that up. And because we changed something in the class, we can't keep using our program for debugging. So we have to restart our program now for us to be able to use the tile set. And let's just draw a tile set first. Well, there's our tile set. And let's just remove our hello world because it's getting in the way a bit. And let's say we want to render 5 tiles of this tile, the second tile. What we could do is we could get a simple for loop, and we could say, okay, tile set. Oh, what functionality does it have? It does have a get subimage. And what we could do is you could say, okay, our tiles here are 32 by 32, so if we want to get the second tile here, we could get 32, 0, and it's going to be 32 by 32, and that gives us another image, and then we can draw that image at, let's say, at 200 starting plus 32 times I, and this is gonna render our first tile somewhere here on the X plus 42 for every time we draw the image. So it's gonna step in steps of 32. And what we also can do here is set the Y and our for loop. And what you see here is we've rendered 5 times this single tile, but we use the same image and we get a sub image every time, and it's not the most efficient way. So what we can do is we can say, okay, but these images all come from the same image, and what we can use is to draw embedded. I hope I typed this right. Oh, what you can see now is that, well, we don't have our image now, and this is because we have to tell Slick that we're starting to use this image, and afterwards we're done with the image. And the way this works is that it's gonna use the same image over and over for drawing these tile, and that way it doesn't have to draw all these images separately. It can just use the resource from our original image. It's basically more efficient. So for drawing tiles, this is a way to do it. But there's also another way, and because you in a lot of 2D games you'll be using tile set or sprite sheets, or basically images with your character in it, and different angles of your character, and you'll be putting those in the same file because it's a lot easier. As you can see with our tile set here, we have a lot of tiles in the same image, and what we can do is we can use the sprite sheet built in Slick2D. Now let's just close the program because we're gonna add another variable here, and let's just call it tiles. And as well we have to import it, and let's say tiles is new sprite sheet. Now, as you can see, the constructor is not right. There's different ways of um, using the constructor of the sprite sheet. You can say you can give the path towards your image, but you can also pass on an image. And because we already loaded an image here, we're just going to do that. So let's say tile set, and then we have to tell it how large our sprites or our tiles are, and there we go. And what we can do now is, as you can see, we can still draw our sprite sheet because it's a subclass of image. You can see all these image methods. But the sprite sheet adds a few extra methods. And let's see, we can um, request the amount of sprites on the horizontal way of the sprite sheet. Um, the same for the verticals, of course. But there's two main methods here: a get sprite and a get subimage. And the difference between these two is that the get subimage is going to use the cached images by the sprite sheet. So what the sprite sheet does when we create the sprite sheet, it's actually gonna create a lot of sub-images of our tile set, and it's just gonna cache them. It doesn't get it doesn't load a lot of extra resources, and it makes for a lot faster performance. And you can still get individual images by just using the get sprite method. But as we just want to render our tiles here, we can just use the get subimage. And when we want to do that is we don't want to give in the pixels this time. We can just say, okay, we want the second image starting from 0, of course, from the first row. Now we want to draw the image, so we could just draw our image because get subimage gives us an image. But the draw embedded was a lot more efficient, so we're going to use that. But because we're using the draw embedded, we still have to tell Slick we're starting to use this tile set, and then we end the usage. So that way this looks a lot the same as you would just do it yourself, but this also caches the images, and it makes it a lot easier for retrieving your sprites here, or your tiles, or whatever you put in your sprite sheet. So let's see if this works. There we go. We can also add back in our for loop. Smaller than 5 and 5++. And because this is not exactly the most efficient way, we can also say, okay, let's start at 200. I want it to be smaller than 400, for example, 32, and let's call this X, and replace this with that. And now we have our tiles from 200 to 400 and 32 pixels apart. So that's it for the images and sprite sheets for tile sets. But there's also a really important thing that you can do with images, and this is the rotation of images. Now, the rotation of images works quite simple. It's an angle in degrees, so if we say that our alien has to rotate 90 degrees, and we then draw our alien at, say, 100, 100, and we restart our program, because I didn't start it up in debug, you can see it's gonna go around like crazy. And this is because I used the rotation in the random method. And remember, the random method is called somewhere around 2000 times per second. So what you see here is just the alien going crazy. And we can also do that in the update, but let's say we want to do that in the init method. And as you can see, the alien has stopped rotating and it just rotated 90 degrees. Now, it's rotated in the wrong direction here, and this is just because I just changed this in the middle of our program. Normally, it would just rotate clockwise, as you can see, rotate it once, 90 degrees. And I think that's it for the images, really. There's a few different methods that you can also use. You can get a flipped copy, and you can also get a scaled copy, and but those are the main functions of the images in Slick2D. So I hope you learned something from this, and next time we'll be looking at geometry shapes and how they work and how we can use them for simple collision detection, for example. So hope to see you next time. Don't forget to subscribe and like this video. Goodbye.